Welcome to Principles Energies Module 2 recording. I'm going to screen share and we're going to get started talking about energy mechanics and forms. So the first thing we're going to talk about is how we're going to categorize forms of energy. And this is the categories that you can find inside your text, but the basic forms that we're going to be talking about is chemical, nuclear, radiant, thermal, sound, electrical, and mechanical. These forms are changing from one form to another, which was something that we covered in the previous chapter when we talked about the laws of conservation of energy. And so without further ado, we're going to go and jump right into the different forms of energy. So this little example is just one of those that show how one form to another, and down below you can see that. And one of the things I'm going to ask you to do inside the coursework for this chapter is actually talk about how the energy is changing from one form to another based on the way its transference is working. So the first one we're going to talk about is chemical energy, which is basically when I take and I create a reaction of multiple molecules together. And there's two ways that we can look at the release of that reaction in chemical energy. The first one is endothermic reactions, which means that I am going to absorb energy from the world around me, most of the time taking in radiant energy, so light, or thermal energy, heat. And then the other form is exothermic reactions, which is when the energy gives off, when the energy is put back out into the world during the chemical reaction. And a lot of times this also happens in the form of radiant energy, light, or thermal energy, heat. One of the best examples in nature of endothermic chemical reactions is photosynthesis, which is a fabulous example of radiant energy becoming absorbed and becoming stored within the plant in its set of actions. So I'm taking in radiant energy and I'm creating a chemical storage, which then if I do certain things, I can actually unleash the energy for myself, or the plant will do it for itself when it shares its own energy in the form of photosynthesis throughout the plant. Exothermic reactions can happen spontaneously, unlike endothermic reactions, which don't tend to happen spontaneously and take work to do. Exothermic reactions can happen spontaneously when certain characteristics are met. For example, think of flash points. Certain items, when heated to a certain point, will catch on fire. That will create that spontaneous reaction, as long as the conditions are met to have that reaction. And in the example we can see here, the chemical reaction that the flash point has been met, so it's heated and it's hit the flash point, and the energy being released is radiant, light, and heat, thermal. The next form of energy that we're going to talk about is nuclear energy. So the previous one was dealing with molecular structures and how they're reacting with one another. This energy transference is going to deal with the atom itself. So I'm going to take an atom, and I have my protons and my neutrons in the nucleus of the atom, and I have my electrons on the outside of my atom. If I were to break the atom apart and make two different elements, so I break it apart and I make two different elements, I am creating nuclear energy forms. And I can do the breaking apart of that, and that is what we call when we say we have a fissionable particle, so that's fission. And or I can take and make it a bigger element, something with more protons within its nucleus, and that is called fusion. So when I'm actually playing with the atomic structure of the item, I am doing nuclear energy. And so here's some examples of fission and fusion within its stages. And we're going to talk more about all these energy forms in various chapters. So this is just introductions. The next one is radiant energy, also known as electromagnetic radiation, can be measured in waves or photon particles. So I have two ways that I can measure radiant energy. And depending on the wave of the radiant energy, which white light carries many different waves of energy, right? If I have a specific wavelength of energy, I can also observe specific characteristics. And once again, we're going to get into this actually quite a bit when we talk about solar panels. And so it's all coming. And this is the example in the book where they throw in the transference of light energy to a solar panel. Solar panels are poured with silicon that have electron valence separation. We're going to go through all these terms. Don't stress. They have electron valence separation, which allows electrons to jump. So that transference makes a direct current of electricity, and the electricity can then go out onto the grid directly. The cool thing about solar panels is it doesn't require a kinetic mechanical part to create that electrical current. So it's very interesting. Thermal energy is measurable heat energy. So a lot of times when we measure thermal activity of something, we're saying how excited is the atoms, or how excited is the molecules, how excited is the structure. And a lot of times we can observe that on a microscopic scale as motion, so vibration, and they're bumping into one another, which can create transference. So thermal energy is your heat energy forms. Sound energy. Sound energy requires something to move through. So sound energy cannot occur without something for the radiant action to move through. It could be a liquid. It could also be a solid material, some solids, transference of sound through it, but not very far. It gets dulled very quickly. And then, of course, atmosphere, air is required. And so you have to have something to move through, but basically you create a deformation within the material that the sound energy is moving through, and it's moving at its consistent speed, and that deformation moves forward through it. So it's kind of like a push forward. So there can be a directionality to sound energy. Electrical energy can also have a directionality to its set. Electrical energy. Electrical energy is electron-based. So I have, once again, my atom, where I have my nucleus, which has my protons and neutrons, and that deals with nuclear energy if I do anything to that. But outside of it, on the valence shell, I have my electrons spinning around. And if I create a jumping from one valence shell to another, and then even from one atom's valence shell to another atom's valence shell, that the electron jumping is electrical energy. So that is electrical energy at its finest as it's moving through. The way that we get a current on our electricity is we send electrons in one direction. So the electron gets excited on one side and it jumps along to another one. And because there's an electron right behind it moving in that one direction, I can create a current. In actuality, if I didn't have that constant bombardment in one direction of electrons moving, I wouldn't have a current, and the electrons would just jump around till they find where they fit best within the various valence shells. Finally, the next form of energy is mechanical energy. This is the one everyone tends to be most familiar with. We can measure it two ways, in kinetic and potential energy. Potential is the energy at rest. Kinetic is the energy in its motion. So mechanical energy is energy in motion. We always see the little hill with the roller coaster. This is also a very common example of kinetic energy. So I have potential up here, and then the rest of the ride is all kinetic. I am in motion while I'm moving through. Here is some examples of kinetic energy in action in some of the sustainable ways. So here you have a water wheel. So the water is pushing the wheel, and we have a wind turbine. Once again, the air, in this case, is pushing the wheel or rotational blades. So forms of energy in review, you have mechanical, which you can think of in two forms, kinetic and potential. Chemical, which you can think of in two forms, endothermic and exothermic. Nuclear, which you can think of in two forms, fission and fusion. Radiant, which is light waves, and can be measured in two forms, waves or photon particle, thermal, which is heat energy, sound, which is deformation of material energy, and finally electrical, which is the electrons jumping. So there you go. That is a review of all your energy forms. And I'm going to stop the video here so that I can post it. And then I will pick up with Newton's laws in a moment.